Imagine you are standing at the edge of a void so vast that light itself, the fastest thing in existence, takes months just to crawl around its circumference. Most of what you've been told about black holes is fundamentally incomplete. You've been taught they are hungry shadows, the remnants of dead stars. But the objects we are discussing today are something else entirely. They are physical impossibilities that challenge the very timeline of our universe. Some theorists whispered in the dark corners of the internet suggest these aren't just big objects, but cosmic glitches, regions where the simulation of our reality can no longer render detail, resulting in a literal hole in the fabric of space-time. Others suggest they are fossils, singularities that survived the collapse of a previous universe and were carried over into our own. Today, we aren't just looking at a list of big numbers. We are investigating a mystery that sits at the absolute ceiling of what physics permits. We are going to climb an infinite staircase, scaling the heights of reality until our math, our intuition, and our very sanity begin to buckle. This is the terrifying size of the largest black hole ever discovered. To begin this journey, we have to start with something you think you understand. Hold a single grain of sand between your thumb and forefinger. In this scale, that grain of sand is the Earth. To find the Sun, you'd need a beach ball about 10 feet away. It's a comfortable, manageable scale. But the moment we leave our solar system, the staircase begins to steepen. Most black holes in our galaxy are what we call stellar mass black holes. They are formed when a massive star collapses, packing the mass of perhaps 10 or 20 suns into a space no wider than a small city. If one of these appeared at the edge of our solar system, you wouldn't even see it. You would only feel the subtle, malevolent tugging on the orbits of distant comets, a ghost pulling at the threads of our gravity. These are the predators behind the glass, familiar, dangerous, but cosmically trivial. But as we ascend the staircase, we leave the familiar territory of dead stars and enter the realm of the supermassive. At the heart of almost every large galaxy sits a gravitational monster. In our own Milky Way, 26,000 light-years away, hidden behind thick curtains of dust and gas, lies Sagittarius A. It weighs 4 million times the mass of our Sun. To visualize that, take every planet, every moon, every asteroid, and every grain of dust in our solar system. That entire collection of matter is only 1% of the mass of our Sun. Now, multiply that Sun by 4 million. This is the object that anchors our entire galaxy. It is a formidable giant, but in the context of what is coming, Sagittarius A is nothing more than a house cat. The next step up the staircase takes us to Messier 87, or M87, the first black hole humanity ever managed to photograph. M87 is not 4 million suns, it is 6.5 billion. If Sagittarius A is the house cat, M87 is a full-grown bull elephant. Its event horizon, the point of no return, is 38 billion kilometers wide. If you dropped M87 into the center of our solar system, its shadow would swallow every planet, every moon, and Pluto itself, extending far out into the frozen void of the Kuiper Belt. Light would need 5 days just to circle it. At this point, your brain's ability to convert numbers into meaning begins to flicker. You can say 6 billion, but you cannot feel it. Yet, as we reach the 10 billion solar mass mark, the staircase disappears into a thick, suffocating fog. This is the transition from supermassive to ultramassive. These aren't just bigger versions of the black holes we know. They live in different environments and grow through mechanisms that seem to cheat the laws of physics. This is the point where the infinite staircase stops being a metaphor and starts being a psychological barrier. We are entering the regime of the outliers, the objects that sit so far outside the standard distribution of cosmic size that they shouldn't exist. For decades, the undisputed king of this regime was TON 618. When astronomers first looked at it, they didn't even know what they were seeing. It appeared as a faint violet dot, a decidedly violet speck in a 1957 survey. They thought it was a star. They were wrong. It was a quasar, a blazing lighthouse powered by a black hole so massive it outshines 140 trillion suns. Its mass was originally estimated at a staggering 66 billion times that of our Sun. To put that in perspective, a single black hole weighing more than every star in the Milky Way combined. But there is a problem with the 66 billion Sun figure. It represents a point where our measurement tools begin to buckle. We cannot weigh these monsters directly. We have to look at the speed of the gas orbiting them. For Towen 6 volt, that gas is moving at 10,000 kilometers per second. However, because the quasar is so bright, the radiation itself might be pushing the gas, making it move faster than gravity alone would dictate. This is like trying to weigh someone on a scale during an earthquake. The forces of light are shaking the measurement. Some revisions suggest it might only be 40 billion suns. This uncertainty is the first crack in our confidence. At the ultramassive scale, the leaderboard of the largest black holes is written in pencil, not ink. We are tracking monsters through a haze of 10 billion years of space and time, using indirect clues to guess at the weight of objects that shouldn't have been able to grow that large in the first place. Standard physics says a black hole has a speed limit for growth called the Eddington limit. If it eats too fast, the radiation from its meal pushes the rest of the food away. To reach 66 billion suns, or the even more terrifying 100 billion suns of the current record holder, Phoenix A, these objects would have had to feed at their absolute limit since the dawn of time without ever stopping to breathe. This brings us to the deeper mystery, the pre-universe fossil theory. If these objects couldn't have grown this large in 13 billion years, then perhaps they didn't. Perhaps they are the seeds of a previous iteration of existence, singularities that survived the Big Bang and began our universe, already weighing billions of suns. Or perhaps they are feeding on something we cannot see. Dark matter, because dark matter doesn't produce radiation. It doesn't push back. It is a cheat code for growth, allowing a black hole to bypass the Eddington limit and swell to impossible proportions in the dark. As we stand here at the end of Chapter 1, look back down the staircase. Earth is a grain of sand. The Sun is a beach ball. Sagittarius A is a house cat. M87 is an elephant. But as we look up into the fog toward Phoenix A and the 100 billion sun wall, the animals disappear. The comparisons fail. We are left only with a number that represents a glitch in our understanding of time and space. We are no longer looking at things, we are looking at the boundaries of the simulation. And the terrifying truth is that at this scale, the event horizon is so large and the gravity so gentle at the edge that you could cross into the void and never even know you were dead until the universe outside simply ceased to exist. We have reached the point where the staircase ends and the fall begins. Now that we've climbed the staircase and the familiar world has fallen away, we find ourselves in an arena where the very idea of a ranking begins to dissolve into a statistical fog. We are entering a domain dominated by two gravitational titans, each laying claim to a throne that might not even exist. In one corner, we have the long-reigning heavyweight champion, TON 618. In the other, a terrifying newcomer that pushes the absolute boundaries of what we believe to be physically possible, Phoenix A. But before we can crown a winner, we have to address the unsettling truth about the leaderboard itself. When you read a headline about the largest black hole ever discovered, you are seeing a number that looks as solid as a mountain. But behind the scenes, that number is written in pencil, and the eraser is always busy. To understand the weight of this cosmic struggle, we have to go back to 1957, to the Tonantzintla Observatory in Mexico. Two astronomers, Braulio Iriarte and Enrique Chavira, were scanning the northern sky, looking for white dwarfs, the faint blue remnants of dead stars. They were recording dots on photographic plates, looking for specific shades of violet that indicated extreme heat. they found one dot that was decidedly violet, a speck of light so unremarkable that they simply labeled it entry number 618 in their catalog. For over a decade, this giant hid in plain sight, mistaken for a common star sitting in our own backyard. It wasn't until 1970 that the true nature of Tone 618 began to emerge. Radio emissions were detected coming from that tiny violet dot, and subsequent spectral analysis revealed a red shift so massive it broke the scales of 1960s astronomy. TON 618 wasn't a nearby star, it was a quasar sitting 10.8 billion light-years away. It was a relic from a younger, more violent cosmos, and it was shining with a luminosity of 140 trillion suns. This single point in space was pouring out more energy than every star in the Milky Way combined, many thousands of times over. When astronomers tried to weigh the beast powering this engine, they looked at the gas clouds swirling around it, moving at a staggering 10,500 kilometers per second. Using these velocities, they calculated a mass that seemed like a typo, 66 billion times the mass of our Sun. This number cemented Tone 618 as the ultimate heavyweight champion for decades. It was the clean benchmark, an object whose mass was derived from direct spectroscopic observations of gas actually moving within its gravitational grip. But in 2019, the leaderboard experienced its first major tremor. A new study re-examined TON 618 using a different spectral line, the carbon-4 line, and found that the gas might be moving slower than previously thought, perhaps only 2,700 kilometers per second. This lower velocity translated to a revised mass of 40.7 billion suns. The king hadn't just been challenged, its very foundation was vibrating. It turned out that the 66 billion figure might have been an illusion caused by radiation pressure. The light of the quasar was so intense it was literally pushing the gas away, making it move faster than gravity alone would dictate. While the established king was being reassessed, a new challenger emerged from the most inhospitable place on Earth. In 2010, a team using the South Pole Telescope in Antarctica detected a massive signal from the constellation Phoenix. They found a galaxy cluster so enormous that its mass is measured in quadrillions, a single gravitational structure weighing as much as 1,000 Milky Ways. At its heart sat a central galaxy, and inside that galaxy sat an object that would make Tone 618 look like a mere placeholder. This is Phoenix A. Initial models of its growth, the way it interacts with the surrounding superheated gas, and the sheer volume of stars it was manufacturing led researchers to a number that shouldn't exist: 100 billion solar masses. If the 66 billion of TON 618 was a terrifying outlier, the 100 billion of Phoenix A was a physical emergency. 100 billion suns is the point where our current understanding of the universe starts to buckle. It is the soft ceiling, the theoretical maximum where a black hole should stop being able to grow because its own radiation is so powerful it starves itself of fuel. But here is where the battle for the throne becomes truly unsettling. Phoenix A's 100 billion sun mass isn't a direct measurement. It is the result of modeling. Because it is 5.7 billion light-years away, we can't resolve individual stars orbiting it, and we can't clearly see the gas swirling around its event horizon like we can with Tone 618. Instead, scientists had to look at the environment, the cooling gas, the X-ray brightness, and the stellar density, and work backward to figure out how big the black hole must be to cause all that chaos. Some independent assessments of Phoenix A suggest it might only be 10 or 20 billion solar masses, a massive gap that could contain multiple entire galaxies. So, who is the real champion? If you take the highest estimate for Phoenix A, it wins. If you take the revised lower estimate for TON 618, Phoenix A wins by a landslide. But if you take the low estimate for Phoenix A and the high estimate for TON 618, the crown shifts back to the old king. This isn't just a measurement error, it's a revelation of our own cognitive and technological limits. We are staring into a statistical fog where probability distributions overlap, and for the first time, we are realizing that the universe doesn't care about our rankings. The leaderboard is in flux because these objects are so extreme, they break the very tools we use to understand them. In the range of millions of suns, our math is a scalpel. At 100 billion, it's a blunt instrument. We are tracking these monsters across billions of years of space and time, using indirect clues to guess at the weight of objects that shouldn't even exist according to our most conservative models. What we are witnessing is not a simple competition for a title, but a struggle between observation and theory. TON 618 represents the observational limit, the most massive thing we've actually measured with a spectrometer. Phoenix A represents the theoretical limit, the most massive thing our equations say can possibly be created. They are two different kinds of certainty pointing toward two different kinds of monsters. And as we stand in the middle of this battle for the throne, we realize the terror isn't which number is bigger. The terror is that at this scale, the difference between 40 billion and 100 billion is a gap so vast our minds can't even feel it. Yet it's a gap that could contain the entire history of our galaxy. We have reached a boundary where human understanding reaches its current limit, and the universe, indifferent and immense, simply keeps going. We are looking at objects that are no longer just big things in space. They are monuments to the fact that gravity, given enough time, will eventually build something so massive that our ability to even rank it will fail. And it's only as we investigate why Phoenix A is allowed to reach that 100 billion sun wall that we begin to suspect it might not be growing by the rules we've been taught. It might be cheating. When we speak of Phoenix A and its staggering 100 billion solar mass estimate, we are no longer just discussing a large object. We are discussing a mathematical emergency. In the world of astrophysics, there is a concept known as the 100 billion sun wall, a theoretical ceiling that suggests the universe itself might have a hard limit on how large a black hole can ever become. This isn't just a convenient round number. It is the point where the laws of physics, gravity, and light reach a violent stalemate. To understand why this wall exists, we have to look back at the historical discovery of the natural thermostat of the cosmos, the Eddington limit. Sir Arthur Eddington, a pioneer in understanding the internal physics of stars, realized that there is a fundamental balance between the inward pull of gravity and the outward pressure of radiation. Imagine a black hole feeding. As gas and dust spiral toward the event horizon, they heat up to millions of degrees, glowing with a brilliance that can outshine entire galaxies. This light isn't just passive, it carries momentum. It pushes back. If a black hole tries to eat too much, too fast, the light generated by its own meal becomes so intense that it literally blows the rest of the food away. This creates a cosmic governor, a speed limit on growth that should, in theory, prevent any object from reaching the absurd scales of Phoenix A. This is why the 100 billion sun figure causes such a disturbance in our understanding. According to the math, if you start with a seed black hole shortly after the Big Bang and let it feed at its maximum possible rate, the Eddington limit, without ever stopping to breathe, it would take nearly the entire 13.8 billion year history of the universe just to reach that 100 billion solar mass mark. But we know the universe doesn't work that way. Black holes have duty cycles, they feed in bursts, and then go quiet for millions of years as they wait for new material to fall in. For Phoenix A to exist at the wall, it would have had to be a perfect eater, a gravitational machine that never once slowed down in over 10 billion years. Physicist Priyamvada Natarajan and her colleagues at Yale have spent years studying this limit, proposing that the 100 billion sun wall is a soft ceiling imposed by the convergence of multiple independent constraints. It's not just about the Eddington limit, it's about the environment. As a black hole grows, its feedback, the jets and radiation it pours out, heats up the surrounding gas so much that the gas can no longer cool and condense to fall into the black hole. The bigger the black hole gets, the harder it becomes to feed it. Eventually, the monster starves itself. It becomes so powerful that it effectively shuts off its own food supply, creating a self-regulating loop that should stall growth at exactly the point where Phoenix A is currently sitting. But this creates a terrifying paradox. If the theory is correct and the wall is real, then Phoenix A is a miracle, an object parked precisely at the absolute edge of what is possible. Yet, many scientists find miracles in physics to be deeply suspicious. If an object sits exactly at the ceiling, it often means either the theory is perfectly right, or our measurement is wrong, or, most disturbingly, there is a cheat code in the physics that we haven't yet accounted for. This is where we must look at the lore gaps that standard documentaries often ignore. If Phoenix A is real, it suggests it found a way to bypass the Eddington limit entirely. One obscure theory suggests that these monsters aren't just eating gas and stars which produce radiation pressure, they might be feeding on dense concentrations of dark matter. Because dark matter does not interact with light, it does not produce the radiation pressure that would normally blow the food away. A black hole feeding on dark matter wouldn't have a thermostat. It could gorge itself in the dark, growing at a rate that would make the Eddington limit irrelevant, swelling to 100 billion suns far faster than our current models allow. The 100 billion sun wall represents more than just a limit on size, it represents the limit of our confidence. When we see an object that appears to be pressing its face against the very glass of physical possibility, we have to ask if we are looking at a record holder or a warning sign. Is Phoenix A a confirmation that nature can reach the limit, or is it a signal that our soft ceiling is actually a door to a type of physics we don't yet understand? If the wall is a hard boundary, then Phoenix A is the end of the line, the largest structure that will ever be allowed to exist in our cosmos. It is a monument to the moment gravity finally loses its battle against its own light. But if these objects have found a way to cheat and move beyond the wall, then the scale of the universe might be even more terrifying than we imagined. We are staring at a boundary where our math begins to fail, and the only thing left to guide us is the light of a quasar that has been traveling since the universe was in its infancy. As we stand before this wall, the historical perspective shifts from one of discovery to one of profound unease. We realize that the terror isn't just the number of suns, it's the realization that the universe might have a maximum setting, and we have finally found the object that is dialed all the way to the top. We are looking at a physical limit, a point where the simulation of our reality reaches its rendering capacity and the objects it produces become so extreme they effectively break the rules of the game. The wall isn't just for the black holes, it's for us. It is the place where human understanding reaches its current limit, and the universe, indifferent and immense, simply keeps going. To truly understand the cognitive nightmare of Toan 689, we must move beyond static maps and start looking at it through the eyes of the only thing in the universe fast enough to reach it: a single photon of light. This journey begins in the deep, ancient past, 10.8 billion years ago, long before the Earth, the Sun, or even the Milky Way had fully taken shape. At this time, the universe was a crowded, violent place, still cooling from its birth. Our photon is born in the heart of a young galaxy ejected from a star that has long since vanished from existence. For over 10 billion years, this light has been a silent witness to the expansion of the cosmos, traveling through a void so perfect and so lonely that it encounters nothing for eons. It is a ghost, carrying the image of a younger universe across a distance of billions of light years. As the photon approaches its final destination, the emptiness begins to change. It enters a structure so massive it shouldn't logically exist in such a young universe, a Lyman Alpha Nebula. This is the Cathedral of Toan 698, a vast glowing cloud of neutral hydrogen gas that spans 330,000 light-years in diameter. To visualize this, imagine taking our entire Milky Way galaxy and doubling its size, that is merely the outer envelope of gas illuminated by the monster within. The photon is now flying through a graveyard of sculpted matter, where the black hole's immense radio jets have carved out caverns of plasma and cold molecular reservoirs for hundreds of millions of years. The scale here is already broken, yet this nebula is merely the front porch of the real horror. Deeper in, the light of the universe behind the photon begins to warp and stretch. The photon is no longer traveling in a straight line. The very fabric of space is beginning to curve like a funnel. Ahead of it lies the source of the nebula's glow, the accretion disk. This is the most energetic environment in the known universe, a swirling maelstrom of gas and dust heated to millions of degrees by friction and gravitational compression. Tone 618 is not just a dark hole, it is a quasar, one of the most luminous objects ever detected. It shines with the staggering brilliance of 140 trillion suns. If you were to place this object where the nearest star, Proxima Centauri, sits today, its radiation would turn our night into day and instantly sterilize every square inch of the Earth's surface. The photon is now bathing in energy that dwarfs nuclear fusion, as the black hole converts matter into pure radiation with an efficiency up to 40%, far beyond the 0.7% efficiency of a standard star. The photon is now caught in the final descent. It passes the point where even the most distant human spacecraft, Voyager 1, would be a mere speck of dust lost in the glare. It is flying over a horizon so vast that light itself would need weeks just to circle its circumference. Here, the pre-universe fossil theory begins to feel less like a speculation and more like a necessity. We are looking at a singularity estimated at 66 billion solar masses, an object that outweighs every single star in the Milky Way combined. Traditional physics struggles to explain how something this massive could have grown in the mere 3 billion years the universe had been alive when this light was emitted. The lore of the lore vault suggests that our photon isn't just approaching a large object, it is approaching a survivor, a singularity that may have existed before our Big Bang even occurred, acting as a seed for the very first structures of our cosmos. As the photon nears the event horizon, a strange and terrifying serenity takes over. Because TO1618 is so incredibly large, the tidal forces at its edge, the gravity that would normally tear an object into thin strands of spaghetti, are surprisingly gentle. For a smaller black hole, the difference in gravity between your head and your feet would rip you apart before you even reached the edge. But here, the event horizon is so vast and the curvature so shallow that our photon and even a human observer could cross the 1300 astronomical unit radius without feeling a thing. You would pass the point of no return, a region 30 times larger than the orbit of Pluto, and the universe around you would look perfectly normal for a few moments longer. This is the ultimate deception of the ultramassive. It is a predator so vast that its capture is silent. There are no signposts, no walls of fire, just a quiet, irreversible realization that the outside world has become a memory. Some theorists suggest this region is a simulation glitch, a point where the universe's computational limits are reached. At this scale, the math of general relativity produces infinities, points where our understanding of space and time simply stops making sense. As our photon crosses the horizon, it enters a realm where time itself effectively comes to a halt for the outside observer, yet for the photon, the journey continues into an unknown that physics cannot describe. We are left with a terrifying image, a single point in space that has been sculpting the universe for billions of years, illuminated by the light of 140 trillion suns and enveloped in a nebula twice the size of our galaxy. Tone 618 is more than a record holder, it is a monument to the irreducible uncertainty of our reality. It is a gateway to a deeper mystery. Was it born from the death of stars, or is it a ghost of a dead universe that shouldn't be here at all? As our photon vanishes into the dark, it leaves us with the unsettling truth that the biggest thing we've ever discovered might also be the oldest thing in existence. A fossil from a time before time. We have established that Tone 618 and Phoenix A are not just large, they are physical anomalies that seem to exist in spite of the rules of the universe. But to truly understand why their size is terrifying, we have to look at the math of their growth. If you were to start a stopwatch at the moment of the Big Bang and attempt to build a black hole as large as Phoenix A using every standard tool in the astrophysical toolkit, you would likely fail. There simply hasn't been enough time. This is the forbidden growth, a temporal paradox that suggests these monsters are either much older than the galaxies they inhabit, or they've found a way to cheat the system. To understand the cheat code, you first have to understand the cosmic speed limit. As we've discussed, black holes feed through a process called accretion, where gas spirals inward and heats up, creating a brilliant disk of radiation. This radiation is so powerful that it creates an outward pressure, pushing against the very gas the black hole is trying to swallow. This is the Eddington limit, the point where the inward pull of gravity is perfectly balanced by the outward push of light. It is the natural thermostat of the cosmos. If a black hole tries to eat too much at once, the resulting glare literally blows the food away, forcing the monster into a state of involuntary starvation. Under these rules, a black hole starting from a modest seed would take roughly 50 million years just to double its mass. To reach 100 billion solar masses, an object like Phoenix A would have had to feed at its absolute maximum capacity without ever stopping to breathe or wait for a new merger for the entire 13.8 billion years of our universe's history. Yet, we know that the universe is a messy, chaotic place. Gas supplies are interrupted, galaxies are stripped of their fuel, and black holes often sit dormant for eons. Finding a 100 billion sun giant today is like finding a toddler who already weighs as much as a mountain. It doesn't just challenge our measurement, it shatters our understanding of time. This is where we must enter the shadows of the lore vault and consider a theory that mainstream science is only beginning to whisper about: the dark matter feed. Most of what we see in the accretion disks of objects like Tone 618 is normal matter, gas, dust, and stars that interact with light. But normal matter is the minority. Most of the universe's mass is locked away in dark matter, an invisible substance that doesn't emit, reflect, or absorb radiation. And here is the cheat code. Because dark matter doesn't interact with light, it does not produce the radiation pressure that powers the Eddington limit. Imagine a black hole sitting at the center of a dense dark matter halo like the one surrounding the Phoenix cluster. While normal gas is being pushed away by the blinding light of the quasar, the dark matter continues to fall inward, invisible and unimpeded. It is a silent feast. The black hole can gorge itself on this dark mass without the thermostat ever kicking in. This would allow for sustained super-Eddington growth, a rapid, unchecked swelling that could build an ultramassive monster in a fraction of the time predicted by standard models. In this view, Phoenix A is not a perfect eater of gas, it is a parasite of the dark, ballooning to impossible sizes by consuming the invisible foundations of the universe. But even the dark matter theory doesn't explain the most disturbing observation of all: the early giants. When we look at Tone 618, we're seeing it as it was 10.8 billion years ago. At that time, the universe was barely 3 billion years old. To have reached 66 billion solar masses by then, Tone 618 didn't just have to grow fast, it had to start gigantic. Standard models suggest black holes start from seeds, the remnants of the very first stars, weighing perhaps 100 suns. But if Tone 618 started that small, even constant dark matter feeding might not have been enough to bridge the gap. This forces us to consider the direct collapse hypothesis. Instead of a star dying and leaving behind a small seed, imagine a colossal cloud of gas, 1,000,000 times more massive than our Sun, collapsing under its own weight without ever forming stars. This would create a heavy seed, a black hole born already weighing 1,000,000 or even 1,000,000,000 solar masses. It is a cosmic shortcut, a way to bypass the slow crawl of stellar evolution and jump straight into the supermassive regime. Yet, even this shortcut feels like a desperate attempt to make the math work for objects that shouldn't exist. The forbidden growth of these black holes tells us that our safe understanding of the early universe is likely wrong. We are looking at a clash between observation and theory. The observations, the light from Tone 618 and the X-ray signatures of Phoenix A, are undeniable. The objects are there. But the theory, the idea that they grew through the slow, regulated accretion of matter, is failing. When you stand before the 100 billion sun wall, you aren't just looking at a big number, you are looking at the evidence of a crime against physics. Whether they are feeding on dark matter or were born from the direct collapse of the primordial void, these black holes represent a breakdown of the standard narrative. They are the ultimate beneficiaries of cosmic privilege, existing in the densest environments where the rules were always meant to be broken. But as we push deeper into the history of these monsters, we start to realize that the cheat code might not be a feature of the black hole at all. It might be a feature of the entire simulation. If the growth is impossible, then maybe the growth didn't happen in the way we think. Maybe we are looking at something that was placed there, a foundational pillar of the universe that existed before the stars themselves. This brings us back to the most haunting possibility of all, that these aren't just objects in the universe, but relics from before it began. We are left with a terrifying realization. The size of Phoenix A is not just a measurement of mass, it is a measurement of our ignorance. We see the result, the 100 billion sun giant, but the process that created it remains hidden in the dark, possibly involving a type of physics that bypasses every limit we've ever calculated. As we move forward, we have to ask, if the growth is forbidden, what else is the universe hiding in the shadows of its largest event horizons? The deeper we descend into the shadows of the ultramassive, the more we realize that the numbers we've been discussing, 40 billion, 66 billion, 100 billion solar masses, are not just measurements of weight. They are measurements of a profound temporal crisis. If we follow the standard timeline of our universe, beginning with a singular explosion of light and heat 8 billion years ago, then objects like Tone 618 and Phoenix A simply do not fit. They are chronological anomalies that seem to have skipped the line of cosmic evolution. To understand why, we have to look past the light of our own stars and consider a possibility that is both scientifically radical and philosophically haunting, that these monsters are not the products of our universe, but the ghosts of a dead one. Standard astrophysics tells us that black holes are the remnants of stars. But the ultramassive giants we see today are so large that they defy the star-to-black hole pipeline. Even with the most aggressive cheat codes, such as feeding on invisible dark matter or growing from the direct collapse of massive gas clouds, the math for an object like Tone 618 is still uncomfortably tight. We see Tone 618 as it was 10.8 billion years ago, when the universe was still in its early adolescence. To have reached 66 billion solar masses by then, it would have had to be born already possessing a mass that dwarfs entire galaxies. This brings us to the first great unanswered mystery. What if these singularities didn't grow within our universe, but were inherited by it? Consider the theory of a cyclic universe, a model where our Big Bang was not a definitive beginning, but a transition, a big bounce from a prior reality that collapsed under its own gravity. In this view, before our stars were born, there was another cosmos that lived, aged, and eventually died. As that previous universe contracted toward its final moments, it would have been filled with its own black holes, monsters that had spent trillions of years feeding and merging. Most of the matter from that prior world would have been ground down into the primordial heat of the transition, but the largest singularities, the ultramassive ones, might have possessed enough gravitational inertia to survive the crunch. They would have punched through the boundary of the Big Bang, emerging into our infant universe as prepackaged giants. If this ghost theory is correct, then Tone 618 and Phoenix A are not just big objects, they are the oldest things in existence, fossils from a time before time itself. They are the seeds around which our first galaxies were constructed. While the rest of the universe was still a hot soup like plasma of hydrogen and helium, these survivors were already sitting in the dark, their gravity acting as anchors for the very first stars. This would explain why we find such massive black holes so early in our history. They didn't have to grow from scratch because they were already finished when they arrived. Our entire cosmic landscape might be a garden built around these ancient alien monuments. Imagine standing near the event horizon of Phoenix A and realizing that the darkness you are looking at is older than the light of the Big Bang. This changes the way we perceive the gentle nature of its event horizon. We've noted that because of its 590 billion kilometer diameter, the tidal forces at the edge of Phoenix A are surprisingly weak enough for a human to cross the threshold without feeling the lethal spaghettification that kills near smaller black holes. But if this object is a survivor from a previous universe, that serenity becomes even more eerie. Crossing that horizon wouldn't just be a trip into a hole in space, it would be a journey into the concentrated memory of a reality that no longer exists. This leads us to a second, even more speculative layer of the mystery: the information paradox. In quantum mechanics, information can never truly be destroyed, yet anything that falls into a black hole appears to be lost to the rest of the universe forever. This has led some theorists to suggest that black holes aren't just traps, but storage devices, or even portals. If TON 618 is a remnant of a prior universe, its singularity could contain the encoded DNA of that entire dead world. Every star that was consumed, every civilization that might have existed, and every law of physics that governed that prior reality would be compressed into the point at the center of this 66 billion solar mass giant. It is a library of the infinite, locked behind a door that light itself cannot open. The existence of these ghost singularities also provides a potential answer to the 100 billion sun wall. As we've seen, current models suggest that a black hole's growth should stall once it reaches a certain size because its own radiation becomes too powerful to allow it to feed. But if Phoenix A didn't grow to 100 billion suns within our timeline, if it arrived as a 90 billion sun survivor, it effectively bypasses the limits of our universe's feeding mechanics. It is a guest that brought its own furniture to the party. This would mean the theoretical ceiling we see isn't a limit on how big a black hole can be, but a limit on how much a black hole can add in 13.8 billion years. When we look at the Lyman Alpha Nebula surrounding TON 618, that glowing cathedral of gas twice the size of the Milky Way, we might be seeing the interaction between our universe and a relic of the last one. The 140 trillion suns of luminosity pouring out of the accretion disk are the result of our matter being ground up by a prior singularity. The nebula is the visible evidence of this collision between two eras of existence, a map of energy shaped by a ghost. The alignment of the jets, which span hundreds of thousands of light years, shows us that this monster has been sculpting our reality for as long as it has existed, acting as a master architect of the cosmos. The terror of this realization is not just the scale, but the isolation. If our universe is haunted by these survivors, it means we are living in the ruins of something we can never truly understand. These black holes are the only surviving witnesses to the before. They represent a continuity that we are excluded from, a lineage of gravity that stretches back through cycles of birth and death that make our 13 billion year history seem like a heartbeat. We are like ants building a nest on the surface of a buried ancient city, unaware that the pillars beneath us were carved by a civilization we will never see. In online communities and deep lore discussions, some take this a step further, proposing that these ultramassive black holes are the reason our universe is habitable at all. By acting as primordial anchors, these ghosts allowed the first galaxies to form much faster than they would have through the slow, random clustering of gas. Without the massive gravitational well provided by these survivors, the matter in our early universe might have remained too diffuse to form the complex structures that eventually led to us. We may literally owe our existence to the remnants of a world that had to die so ours could begin. But this also implies a grim ultimate fate. If black holes are the only things that can survive the transition between universes, then they are the only permanent structures in the multiverse. As our universe ages and expansion carries the galaxies farther apart, these monsters will remain, slowly evaporating over timescales so long that they are effectively infinite. Eventually, everything else, every star, every planet, every atom, will be gone, leaving only these silent, ultramassive ghosts drifting in a cold, dark void. They are the alphas and the omegas, the first things to arrive and the last things to leave. As we stand at the threshold of the 100 billion sun wall with Phoenix A, the ghosts of a dead universe theory offers a way to reconcile the impossible. It transforms a measurement error or a statistical fluke into a profound revelation about the nature of time. We don't just see a large object, we see a bridge. The reason Phoenix A is pressing against the wall of what the universe permits is because it isn't fully of this universe. It is an intruder from a previous regime, a gravitational anomaly that sits at the very edge of our understanding because it represents the boundary between our reality and whatever came before it. This perspective forces us to confront the fact that our ranking of these black holes is inherently flawed. We aren't just comparing sizes, we might be comparing the survivability of different singularities across the Big Bang. TON 619 might be a younger, smaller survivor, while Phoenix A could be the ultimate heavyweight champion of the entire cyclic history of the multiverse. The statistical fog we see when we try to measure them, the overlapping probability distributions, and the leaderboard written in pencil, is actually the blurring effect of trying to look through the lens of one universe into the mechanics of another. Ultimately, the terror of TON 618 and Phoenix A lies in their silence. They sit at the centers of their respective cathedrals, illuminated by the dying light of trillion sun accretion disks, but they tell us nothing. They are the ultimate keepers of secrets, the only things that know what the prior universe looked like, what its stars were made of, and why it ultimately collapsed. We are left on the outside, staring at the event horizon, trying to use our modest math and our limited intuition to weigh the weightless and time the timeless. We have reached the point in our journey where the infinite staircase has led us into a graveyard. The ultramassive black holes are the tombstones of a dead reality, yet they are the very things that give our current reality its shape and structure. They remind us that the universe is far older and more complex than a single 13 billion year timeline can account for. And as we gaze into the 100 billion sun abyss of Phoenix A, we have to wonder, if it survived the birth of our universe, will it also survive the end of it? Are we merely a brief, flickering chapter in the biography of a singularity that has already seen the end of everything once before? This realization doesn't just lower our confidence in our measurements, it lowers our confidence in our own importance. We are a species that has only existed for a fraction of a percent of our universe's life, trying to understand objects that may have existed before the first atom was ever formed. The ghosts of a dead universe don't just challenge our physics, they challenge our sanity. They are the ultimate outliers, the things that shouldn't be here, yet are the only reason we are. And the most terrifying thought of all is that if we ever did cross that serene, silent horizon to find the truth, we would find that the universe we call home is nothing more than a passing shadow on the surface of a deeper, darker, and much older reality. When we think of black holes, our minds immediately conjure images of the ultimate cosmic violence. We imagine stars being torn apart like tissue paper, light being twisted into screaming halos of fire, and any matter unlucky enough to wander too close being stretched into thin, agonizing ribbons of atoms. This is the process we've come to know as spaghettification, the brutal physical manifestation of a gravitational gradient so steep that it can pull harder on your feet than it does on your head, snapping the bonds of your biology before you've even reached the dark threshold. In the popular imagination, the event horizon is a jagged, lethal blade. But as we reach the scale of the ultramassive, the universe plays a terrifying trick on our intuition. For the largest black holes ever discovered, like the 100 billion sun giant Phoenix A, the event horizon is not a site of violence. It is a place of profound, unsettling serenity. This is the era of the serene executioner. To understand why a monster that outweighs all the stars in the Milky Way combined is gentle, we have to look at the geometry of the void itself. In a small, stellar mass black hole, the kind created by a single dying star, the singularity is packed into a tiny space. Because the event horizon is so close to the center, the gravity changes drastically over very short distances. If you were to approach a 10 solar mass black hole, the difference in pull between your toes and your crown would be millions of times stronger than the gravity of Earth. You would be dead long before you ever saw the dark circle. But as a black hole grows, its event horizon expands much faster than its tidal forces. By the time we reach Phoenix A, the event horizon has swollen to a diameter of 590 billion kilometers. This is a region of space 4,000 times the distance between the Earth and the Sun. Because this horizon is so staggeringly vast, the curve of space-time at the edge is nearly flat. The gravitational gradient is so shallow that if you were to float across the threshold of Phoenix A, you wouldn't feel a thing. Your feet and your head would experience almost identical levels of pull. There would be no snapping of bones, no stretching of atoms, no physical indication that you had just left the known universe forever. This is the ultimate deception of the ultramassive. It is a predator so immense that its capture is silent. It doesn't need to hunt you. It simply waits for you to drift into a region of space that looks and feels exactly like the void you just left, unaware that the exit has been permanently deleted from reality. Imagine, for a moment, that you are an observer on a spacecraft approaching the event horizon of Phoenix A. You have been traveling for years to reach this boundary. You look out the viewport, expecting to see a wall of fire or a shimmering distortion in the fabric of space. Instead, you see nothing. The stars behind you are still visible, though slightly shifted in color. The dark abyss ahead of you is immense, but it doesn't feel like a hole. It feels like a destination. You check your instruments. The clocks on your ship are still ticking normally. Your body feels light, comfortable, perhaps even peaceful. You look at your navigation screen and realize you have just crossed the 295 billion kilometer radius. You are now inside. In any other black hole, this would be the moment of your destruction. But here, inside the serene executioner, you are still alive. You could look back and see the light of our sun, though it would be a faint, reddened ghost of a star 5.7 billion light years away. You could even attempt to turn the ship around. You could fire your engines at maximum thrust, burning through every ounce of fuel in a desperate attempt to return to the universe you knew. And this is the true terror: your engines would work. Your ship would accelerate. You would feel the familiar push against your seat. But no matter which direction you pointed your nose, no matter how fast you traveled, you would only be moving deeper into the dark. Inside an ultramassive event horizon, the very coordinate system of the universe has rotated. What we once called the future is now a physical direction pointing toward the singularity. To try and move away from the center of Phoenix A is like trying to move away from tomorrow. It is a logical impossibility. You are trapped not by a physical wall, but by the fact that every possible path in space-time now leads to the same inevitable conclusion. This is why we call it a serene executioner. It kills you with math, not with force. It captures you with the quiet certainty of a geometric trap. This brings us back to one of the most unsettling lore gaps we identified: the simulation glitch hypothesis. If you can cross a threshold that represents the absolute end of physics without feeling a single physical sensation, is that boundary actually real in the way we understand it? Some theorists suggest that the event horizon of an object like Phoenix A is a rendering limit. In a simulated reality, there is only so much detail the code can provide when gravity becomes this extreme. The serenity of the crossing might be a result of the universe's inability to render the physical consequences of such a massive singularity at the edge. The glitch is the lack of a signpost. The universe hasn't even noticed you've left, because the scale of the object is so large it has effectively bypassed the local rules of collision and violence. Think about the scale of this gentle trap. We previously noted that Voyager 1, humanity's most distant explorer, has been traveling for nearly 50 years. It has covered 160 astronomical units of space. If you dropped Voyager 1 into the center of Phoenix A's event horizon, it would be swallowed whole and still leave 99% of that horizon empty. To reach the edge from the center, the probe would need to travel another 10 times its current distance, and yet, for every second of that journey, Voyager would be dead to the outside world, even as its instruments continued to record a perfectly normal, quiet vacuum. It is a sphere of no return so enormous that entire stellar systems could orbit within it, oblivious to their fate, for years before the inward curvature of space finally became apparent. This is the psychological horror of the ultramassive. With a small black hole, the danger is immediate and obvious. You see the predator, and it destroys you. With Phoenix A, the predator is so big you are living inside its mouth before you even realize it's a living thing. You are the victim of a stealth gravity. The sheer volume of the event horizon means that the point of no return is a vast, empty wasteland where the laws of physics are still functioning on the surface, but the underlying logic has already been severed. This serenity also challenges our understanding of the information paradox. If you can cross the horizon safely, you are carrying information, your thoughts, your biology, your ship's data, into a region where it can never return. Does that information simply cease to exist the moment you cross, or is it preserved in some ghostly state on the surface of the horizon? Some speculative theories suggest that as you cross the serene boundary of a 100 billion sun monster, a holographic version of you is smeared across the 590 billion kilometer surface. To an outside observer, you are frozen forever at the edge, reddening and fading into a permanent static memory. But to you, the journey continues in silence. You have become a ghost in the machine, existing in two places at once, a living being inside the dark and a string of data on the outer shell. As we contemplate the serene executioner, we must confront the irreducible uncertainty of our own perspective. We rank these black holes by mass, but maybe we should be ranking them by their cruelty. A small black hole is an honest killer. It shows you its power and ends you quickly. An ultramassive black hole is a liar. It offers you a peaceful threshold, a quiet descent, and a sky full of stars, all while it slowly erases your existence from the timeline of the universe. It is a monument to the fact that in our cosmos, the most terrifying things aren't always the loudest or the most violent. Sometimes, the ultimate horror is found in a silence so deep and a scale so vast that you can cross the end of the world and never even know you've left. This is the transition point of our journey. We have seen the numbers, we have climbed the staircase, and we have felt the gentle, lethal touch of the serene executioner. But why does the universe allow such a thing to exist? Why are these monsters allowed to sculpt the very fabric of reality on such a massive scale? To find that answer, we have to look away from the black hole itself and toward the cathedrals they build around themselves. We have to look at the light that reveals the dark, the blazing, trillion sun halos that turn these invisible predators into the most luminous objects in the history of time. We must move from the silence of the executioner to the deafening roar of the cathedral. We have spent so much time staring into the abyss of the event horizon itself that we have neglected the most beautiful and terrifying part of the story: what this monster does to the space around it. To understand Tone 617, we have to look past the hole and toward the cathedral it has built for itself. In 2021, using the Atacama Large Millimeter Array, or ALMA, astronomers discovered that Tone 618 is not just a point of light in the dark. It is the center of a structure so vast that it makes our entire galaxy look like a rounding error. This is the Lyman Alpha Nebula, a glowing ultraviolet shroud of neutral hydrogen gas that spans at least 330,000 light-years in diameter. If you need a sense of scale, our Milky Way is about 100,000 light-years across. This nebula is more than 3 times that size. It is a structure so immense that if you could see it from a neighboring galaxy cluster, it would dwarf our home galaxy the way a cathedral dwarfs a birdhouse. But this nebula isn't just a cloud of gas sitting passively in space. It is a fossil record, a 3-dimensional map of every violent outburst this black hole has had for the last several 100 million years. Every time Tone 6118 feeds, it doesn't just swallow matter, it screams. The intense radiation and the powerful radio jets produced by the central engine scream into the surrounding void, carving out caverns in the gas and driving massive outflows of molecular material. Within this nebula, astronomers have found 2 distinct components: an inner outflow of gas being physically pushed by the jets, and an even larger reservoir of cold molecular gas in the circumgalactic medium. Each of these components contains approximately 50 billion solar masses of material. Think about that. There is more mass in the residue surrounding Tone 618 than there is in all the stars of the Milky Way combined. This is why we call it the Lyman Alpha Cathedral. It is an architectural marvel of gravity and light. When you look at the images of this nebula, you are seeing the black hole sculpting its environment on scales that defy human logic. The molecular outflows are perfectly aligned with the radio jets, showing that this single gravitational engine has been the master architect of this entire region of space for timescales measured in hundreds of millions of years. The jets act like cosmic blowtorches, clearing out paths through the gas and regulating the very fuel that the black hole needs to grow. It is a self-regulating monument, a temple of hydrogen illuminated by the 140 trillion sun glare of the quasar. But why does it glow? The name Lyman Alpha refers to a specific wavelength of ultraviolet light emitted when a hydrogen atom's electron drops to its lowest energy state. In the case of TON 618, the black hole's central engine is so bright that it acts like a gargantuan ultraviolet lamp, ionizing the hydrogen atoms in the surrounding nebula and causing them to glow with a haunting violet light. This is visualizing the invisible. Normally, this cold gas would be dark and undetectable, but because it is trapped in the presence of an ultramassive monster, it is forced to reveal itself. We are seeing the invisible foundations of the universe, the gas that normally hides in the intergalactic medium, lit up by the most powerful flashlight in existence. This brings us to a deeper, more unsettling mystery that the standard documentaries tend to ignore. If this black hole is sculpting an environment twice the size of our galaxy, what is the ultimate purpose of this structure? In online communities and scientific circles, some have proposed that these nebulae are not just byproduct clouds. They suggest that ultramassive black holes like TON 618 are actually nodes or gateways in a much larger cosmic structure. In this view, the Lyman Alpha Cathedral isn't just a tomb for gas, it is a junction point where the dark matter filaments of the cosmic web meet. The black hole isn't just an object sitting in space, it is the anchor for the entire structural integrity of that region of the universe. There is a terrifying elegance to this. If you were to fly through the Lyman Alpha Nebula, you would be traveling through a graveyard of stars and galaxies that were long ago ground into the fine dust that now makes up this shroud. Every atom of hydrogen in that 330,000 light-year span is a witness to the black hole's hunger. It is a Lyman Alpha blob, a term that sounds almost comical until you realize it represents the most extreme environment we have ever seen. It is a place where the distinction between a galaxy and a black hole begins to blur. At this scale, the black hole is the system. The stars and gas are merely the decoration on its event horizon. And yet, for all its brilliance, the cathedral is a place of absolute isolation. Because the radiation from Tone 6 is so intense, the surrounding nebula is a lethal zone. Any planet that attempted to form within this 330,000 light-year diameter would be constantly sterilized by X-rays and ultraviolet bursts. It is a beautiful, glowing wasteland. It reminds us of the simulation glitch theory we discussed earlier. If the universe is a simulation, then perhaps these massive glowing nebulae are rendering artifacts, regions where the energy output is so high that the system has to highlight the surrounding matter just to keep track of the gravitational data. The cathedral isn't just a physical object, it's a warning sign from the code itself. The scale of the sculpting is perhaps the most difficult thing to process. We often think of black holes as small objects because they are so dense. But the influence of Tone 6 is not small. Its jets reach out for hundreds of thousands of light years, pushing 50 billion suns worth of gas as if it were nothing more than smoke in a breeze. This is the true definition of ultramassive. It is a mass so great that it can dictate the history of a volume of space that would take light 300,000 years just to cross. It is a level of power that moves beyond physics and into the realm of the divine. As we look at the Lyman Alpha Cathedral, we realize that Tone 618 is not just a consumer of reality, it is a creator. It has created a structure of light and gas that is more permanent than the stars themselves. Galaxies will merge, stars will explode, and the Milky Way will eventually collide with Andromeda and change its shape forever. But the cathedral of Tone 618 will remain, its hydrogen shroud kept glowing by the relentless power of the singularity at its heart. It is a monument to the permanence of gravity in a universe that is otherwise defined by change. But there is a final, haunting question that remains. If this nebula is a fossil record, what is it telling us about the origins of Tone 618? As we've explored, the pre-universe fossil theory suggests this black hole survived the Big Bang. If that is true, is the Lyman Alpha Nebula the original matter of that dead universe? Are we looking at the ash of a previous cosmos illuminated by the light of our own? Could the reason the nebula is so large be that it contains the remnants of an entire galaxy that existed before our time even began? We are left staring at a structure that should not exist, built by an object that challenges the limits of growth, in a universe that might be much older than we are told. The Lyman Alpha Cathedral is the bridge between the physics we understand and the mysteries we are only beginning to glimpse. It is the visual proof that at the ultramassive scale, the universe stops being a collection of objects and starts being a single, interconnected web of gravity and light. And as we move closer to the center of this cathedral, toward the singularity itself, we realize that the most terrifying thing isn't the size of the nebula or the mass of the whole. It is the realization that the architecture we are seeing is actually a breakdown, a point where the simulation can no longer hide the fact that there is a literal hole in the middle of everything. As we move past the glowing gas of the Lyman Alpha Nebula and approach the heart of the monster itself, we aren't just leaving behind the familiar lights of our galaxy, we're leaving behind the very logic of our reality. Up until now, we have treated black holes as physical objects, enormous, heavy, and terrifying, but ultimately things that exist within the framework of space and time. But at the ultramassive scale, particularly with a giant like Phoenix A, we must confront a possibility that is whispered in the darkest corners of theoretical physics and debated on the most speculative forums of the internet. We must consider the possibility that these objects are not just parts of the universe, but glitches in its code. We are entering the realm of the simulation limit. In the world of computer science, there is a concept known as a computational limit. If you try to render a world that is too complex, or if you ask a program to calculate a value that is too large, the system eventually breaks. It reaches a point where the underlying rules of the software can no longer handle the input, resulting in a crash, a freeze, or a divide by zero error. For over a century, The greatest minds in physics have been staring at exactly such an error at the center of every black hole. We call it the singularity. It is a point where general relativity, the math that describes everything from the fall of an apple to the orbit of a planet, produces infinities. It is a point where the density becomes infinite and the volume becomes zero. In any other context, a scientist would look at an equation that produces infinity and realize the math has failed. Inside a black hole, the math doesn't just fail, it surrenders. This leads us to the most unsettling lore gap of all, the idea that ultramassive black holes represent regions where the simulation of our universe can no longer render detail. If our reality is indeed a sophisticated program, then a black hole is a localized system crash. The event horizon isn't just a boundary of light, it is a censorship screen. It is a protective barrier the universe places around a region where the code has broken down, preventing the error from spreading to the rest of the system. And if this is true, then the sheer size of Phoenix A's event horizon, a 590 billion kilometer sphere of silence, represents the largest dead zone in the history of our reality. It is a region 4,000 times the distance from the Earth to the Sun where the laws of physics have been effectively deleted. Think about what it means for a glitch to be that large. In a stellar mass black hole, the glitch is small, a tiny puncture in the fabric of space. But in Phoenix A, the glitch has swallowed a volume of space that could contain dozens of solar systems. This isn't just a minor error. This is a systemic failure of the simulation on a galactic scale. This brings us to the holographic principle, a theory that suggests all the information contained within a volume of space is actually encoded on its boundary. If we apply this to the simulation theory, the event horizon is like a hard drive surface. Every star, every planet, and every photon that has ever fallen into Tone 618 or Phoenix A isn't gone. It has been converted into raw data and smeared across the horizon. The black hole isn't eating matter, it's archiving it. But why would a simulation need such massive trash bins or data archives? This is where the mystery deepens. Some theorists propose that the ultramassive black holes are nodes or gateways in a much larger cosmic structure. If the universe is a network, then these black holes are the central processing hubs managing the gravitational integrity of entire galaxy clusters. The reason the math breaks down at the center is that we are looking at the hardware from inside the software. Just as a character in a video game could never understand the silicon and electricity that powers their world, we cannot understand the singularity because it exists outside the parameters of the program we inhabit. This perspective changes the way we look at the 100 billion sun wall. If there is a limit to how large a black hole can grow, it might not be because of radiation pressure or a lack of fuel. It might be a memory limit of the simulation. Perhaps the universe simply cannot render a single point of mass larger than 100 billion suns without the entire system crashing. Phoenix A, sitting precisely at that limit, is the cosmic equivalent of a warning light. It is the point where the simulation is redlining, struggling to maintain the gravitational data of 100 billion stars in a single location. The instability we feel when trying to measure these objects, the way the numbers seem to shift and the rankings are written in pencil, might not just be a limitation of our telescopes. It might be an inherent instability in the object itself, as it fluctuates at the very edge of physical possibility. Consider the information paradox through this lens. In quantum mechanics, information can never be destroyed. But if a black hole is a glitch, then that information is being uninstalled from our reality. This creates a fundamental conflict between the rules of the simulation and the rules of its subroutines. The result is the firewall paradox. The idea that the event horizon is a region of high-energy error messages that destroy anything attempting to cross it. Yet, as we saw in the previous chapter, for an ultramassive black hole, the horizon is serene. This serenity is the ultimate glitch in the matrix. It is the system telling you everything is fine, even as you cross a threshold into a region of space that no longer exists in the active memory of the universe. As you drift across the 590 billion kilometer threshold of Phoenix A, you are essentially clipping through the map of reality. Behind you, the universe continues to run its program, with stars burning and galaxies merging in a 13 billion year narrative. But ahead of you, the code has stopped. There is only the singularity, the point of infinite density where the simulation has reached its final, unresolvable calculation. Some philosophers argue that this is why we will never have a theory of everything that unites gravity and quantum mechanics. We are trying to find a single equation for a world that is made of two different layers: the rendered world of light and atoms, and the hard-coded world of the singularity. The terrifying size of the largest black hole ever discovered is therefore a measurement of the universe's limits. When we look at TON 617, we are looking at 66 billion suns worth of space that has been deleted from the playable area of the cosmos. When we look at Phoenix A, we are looking at a 100 billion sun hole in the fabric of the simulation. These are not just objects, they are monuments to the fact that our reality is not as solid as it seems. They are proof that even the universe has its boundaries, and that if you push the parameters of mass and gravity far enough, the system will eventually break. This leads us to a final, haunting thought. If the black holes are glitches, and they are continuing to grow and merge over trillions of years, what happens when they finally consume the entire simulation? In the far, far future, long after the last star has burned out, the universe will consist of nothing but these massive data archives drifting in the dark. Will the simulation simply shut down? Or will the accumulation of so much deleted data trigger a system restart, a new Big Bang, born from the singularities of the old? In this view, the ultramassive black holes aren't just errors, they are the save files of the cosmos, carrying the raw data of our universe into the next one. We often feel safe because these monsters are billions of light years away. We look at them through telescopes and treat them like abstract math problems. But the glitch in the matrix theory suggests that the danger is much closer than we think. If the rules of physics can break down in the Phoenix cluster, it means those rules are not absolute. They are conditional. They are part of a program that has a maximum capacity. And as we stand on the edge of the 100 billion sun wall, we are forced to confront the fragility of our own existence. We are inhabitants of a world that allows for the existence of 590 billion kilometer voids where time stands still and light is a prisoner. We are living in a reality that is punctuated by holes so large they could swallow our entire history without a trace. As we move into the final stage of our journey, we must ask ourselves, what lies beyond the glitch? If the event horizon is the end of our code, is there another program running on the other side? We have scaled the infinite staircase, survived the battle for the throne, and walked through the silent cathedral of the Lyman Alpha Nebula. We have even looked at the possibility that we are living inside a machine that is breaking under the weight of its own gravity. Now, there is only one thing left to do. We must look at the end of the story, the ultimate fate of the universe and the final irreducible truth that stays behind when everything else is gone. We must go beyond the event horizon one last time to see what the largest black hole ever discovered is really trying to tell us about the end of everything. We have reached the end of our climb, yet as we stand upon the final step of the infinite staircase, the ground beneath us feels less stable than ever. Throughout this journey, we have chased a single definitive answer. What is the largest black hole ever discovered? We looked at TON 16, the violet dot that turned out to be a 66 billion solar mass titan measuring the universe from its infancy. We looked at Phoenix A, the challenger sitting at the center of a galaxy cluster so massive it outweighs 1,000 Milky Ways, allegedly pressing its face against the 100 billion sun wall. But as we conclude this investigation, the real terror we must confront isn't a specific number or a name on a leaderboard. The true horror, the ultimate size we have discovered, is the scale of our own ignorance. We have found a boundary where the very tools of human thought, from our mathematics to our most advanced telescopes, begin to buckle and dissolve into a statistical fog. At this scale, numbers like 40 billion or 100 billion solar masses stop behaving like properties of physical objects and start feeling like arbitrary coordinates in a continuum of excess. For the human brain, which evolved to distinguish between 3 predators or 30, the difference between these two giants is emotionally and cognitively invisible. We can write the figures on a chalkboard, but we cannot feel the weight of them. When we say a black hole is 100 billion times the mass of the Sun, the register of human intuition flatlines. We are carrying a calculator into a realm that exceeds its range, staring at a cosmic ledger where the entries are no longer written in ink, but in the shifting, erasable pencil of estimation and modeling. This instability is the first of our final revelations. We want a winner. We want a definitive king of the void. But as we have seen, the leaderboard is a cloud of overlapping probability distributions. A mass estimate for Phoenix A might be 100 billion suns in one model, but 20 billion in another. TON 618 might be 66 billion, or it might be 40 billion if we adjust for the earthquake of radiation pressure pushing against our measurements. This uncertainty is not a temporary failure of our technology. It is a structural feature of a universe that produces monsters so extreme they overwhelm the signatures we need to identify them. We are trying to weigh the heaviest things in existence from the greatest possible distances, and the universe is pushing back. This brings us back to the most unsettling theory in our lore vault, the idea that these ultramassive black holes are not just big things, but the computational limits of our reality. If the universe is a simulation, then a black hole of 100 billion solar masses is the ultimate divide by zero error. It is a region where the code can no longer render detail, a 590 billion kilometer dead zone where the physics of atoms and light have been uninstalled and replaced by a censorship screen called the event horizon. The serene nature of the crossing we discussed, the fact that you could slide into the mouth of Phoenix A without feeling a single tug of violence, is the ultimate glitch. The simulation has grown so vast at this point that it doesn't even notice you've left the playable area. You are a ghost in a machine that has reached its rendering capacity. And what of the information paradox? If these objects are indeed save files or archives of the cosmos, then their size represents the volume of history they have swallowed. We must consider the pre-universe fossil theory one last time. If TON 618 and Phoenix A are survivors of a prior universe, singularities that endured the collapse of a previous reality to become the seeds of our own, then they are the only permanent things in existence. They are the alphabets of a language we can no longer speak. When we stare at Phoenix A, we aren't just looking at 100 billion suns, we are looking at the compressed memory of an entire dead cosmos that had to vanish so that we could begin. They are monuments to a lineage of gravity that stretches back before the Big Bang, reminding us that our 13 billion-year history is just a single chapter in a much darker and older biography. This realization forces a shift in our perspective. We have spent this documentary scaling up, but perhaps we should have been scaling down our sense of importance. We are a species that has existed for a fraction of a percent of cosmic time, trying to weigh objects that may have existed before the first atom was ever forged. The terrifying size of the largest black hole is actually the size of the gap between what we know and what is true. We have identified the candidates, we have mapped the Lyman Alpha cathedrals they build around themselves, and we have felt the gentle touch of their event horizons, but we cannot be sure of their mass because the evidence is diluted by the very distance and complexity that makes them legendary. In the far future, the universe will become a very different place. The expansion of space will carry the galaxies away from each other until the sky is empty of everything but the Milky Way's remnants. The stars will burn through their fuel and go dark. One by one, the white dwarfs and neutron stars will cool into black cinders. Eventually, there will be nothing left but the black holes. And the largest among them, the 100 billion sun monsters like Phoenix A, will be the last things to leave. They will endure for decillions of years, slowly evaporating through Hawking radiation, acting as the final, silent witnesses to a universe that once contained light and life. When we ask how big is it, we are asking a question that assumes the universe cares about our categories. It doesn't. The Phoenix cluster does not know it is extreme, it simply follows the dictates of gravity. The black hole at its center does not know it is a record holder, it simply persists. The terror we feel is entirely our own, the vertigo of a finite mind trying to grasp an infinite process. The 100 billion sun wall may be a soft ceiling for black hole growth, but it is a hard wall for human comprehension. So, as we look one last time at the violet dot of Tone 618 and the X-ray ghost of Phoenix A, we must accept that the leaderboard will always be written in pencil. We may find a black hole tomorrow that is 150 billion solar masses, or we may find that our current estimates were doubled by a trick of the light. But the number isn't the point. The point is that we live in a universe capable of producing such excess. A universe that allows for the existence of holes in reality so large that light itself takes months just to crawl around their edges. The largest black hole ever discovered is a gateway to the deepest questions in science. It is a monument to the fact that gravity, given enough time, will eventually build something that strains the vocabulary of the very species trying to study it. We have moved from supermassive to ultramassive, and we may yet need a new prefix if the frontier continues to recede. But no matter the name or the number, the conclusion remains the same. These objects are the irreducible outliers of existence. They are signals from a cosmos that operates at scales where human confidence becomes thin and observational certainty becomes fragile. The real mystery isn't which one is the biggest. The real mystery is why the universe would permit such a thing to exist at all, and what it says about the nature of our reality, that the biggest things in it are defined entirely by what they have taken away. We are left at the boundary, looking out into a dark so deep that no light can ever return from it. The largest black hole we have ever found is not a number, and it is not a name. It is a boundary, the place where human understanding reaches its current limit, and the universe, indifferent and immense, simply keeps going.